Today we're taking a look at 8.2 on line, slope, and average rate of change. An equation that can be written in the form ax plus by is equal to c, where a and b are not both 0, is a linear equation in two variables. This form is called standard form. Intercepts. To find the x-intercept, which is the point where the line crosses the x-axis, we let y be 0 and solve for x. To find the y-intercept, the point where the line crosses the y-axis, we let x be 0 and this time solve for y. Now let's look at an example that shows us how to find the intercepts. And we're going to use the two intercepts to do our graph. Consider the equation 3x minus 2y is equal to 6. First, we want to find the x-intercept. Okay, so what we're going to do is we're going to let this y right here be 0. So 3x minus 2 times 0 equals 6. 2 times 0 is 0, so that means we have 3x equals 6. And that means if we divide by 3, that x equals 2. Now note that the x-intercept has two coordinates. It has 2 and the 0 that we plugged in for y. Now to find the y-intercept, we're going to plug in 0 for x. So we'll have 3 times 0 minus 2y is equal to 6. Minus 2y equals 6. Divide by negative 2. And we get y is negative 3. So we get 0, negative 3. Okay, and so my axis is a little bit crooked there, but alright, remember we have our x and our y axes, and I want to plot the 2 points. Let's see if I can get a different color pen. Maybe we'll use red. Okay, 2 zeros over 2 and up 0, and 0, negative 3 would be 0 and down 3. And we can graph our line using the two intercepts. So we have 2, 0 here. That's the x-intercept because it's on the x-axis. This one is 0, negative 3 is the y-intercept because it is on the y-axis. Okay, so now we're looking at graphing lines that only have a single intercept. And I'm going to put both of these on the same graph, but I'm going to put them in different colors. Okay, let's start with y is equal to negative 2. 1, okay, we're talking about y, so here's our y-axis. 1, 2, there's negative 2. And what we're saying is all the y's on all of those points are negative 2. So that gives us a horizontal line. Any line of the form y equals b is going to be horizontal. And it's going to cut through b on the y-axis. Now let's do the other one in blue. X equals 5. 1, 2, 3, 4, 5. Okay, it only has the x-intercept, which is on the x-axis, and this time the x-coordinate remains constant. It's always 5. We have 5, 0, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, and so forth. So for all of these points, x is 5, y can be any number. So when we have x equals a, then we get a vertical line going through a on the x-axis. Okay, the slope or average rate of change The slope of a line is the vertical change over the horizontal change. And we define it as m, we call it m, rise over run, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1 for 2 points on the line. X sub 1 and y sub 1 is the first point, and the second point is x sub 2, y sub 2. Okay, now we want to find the slope of the line that goes through these 2 points. So m, I'm going to let this be x1, y1. This one be x2, y2. And so I'm going to have negative 9 is my y2 minus 7 over 3 minus a negative 2. Notice both times I started with 0.2. So I get negative 16 over a positive 5 would be the slope. Now a vertical line has no slope because the slope is undefined. A horizontal line has 0 slope. And let's see if we can figure out why from this graph up here. That's one of the reasons I did this graph. Let's just take 2 points on the horizontal line. And let's see, that's what, negative 3, negative 2, and this one is negative 6, negative 2. Alright, so if we take, let's call this 0.1 and 0.2, so if we take negative 2 minus a negative 2, that'll give us a plus, over negative 3 minus a negative 6 gives us 0 over 3, which is 0. So the horizontal line has slope 0. Now let's look at the vertical line. Well, let's use this one. This is what, 5, 0, and let's take 5, 3. Let's see what happens here. Okay, in this case, we have, and I'll call this one 0.1 and this one 0.2 down here. So we're going to have 3 minus 0 over 5 minus 5, which is 3 over 0, and that would be undefined. Sometimes we say a vertical line has no slope. Okay, so horizontal line has 0 slope, a vertical line has no slope because the slope is undefined. Now what we find is parallel lines will be have the same slope, so their m would be the same in both cases, whereas perpendicular lines, those are lines that meet at a right angle, would have slopes that are negative reciprocals. And actually what happens is slope of the first line times slope of the second line. When they're perpendicular, the product will be a negative 1. Okay, now your next task will be to view the sample problems for section 8.2.